Okay, so I'm just going to post a video here of Hess's law, okay? Basically, there's two ways this can be asked. The first way is that you can be asked for the overall heat of reaction, or it could be overall heat of combustion, or you can be asked for a heat of formation. Okay, so there's in general two different ways in which this can be asked. I'm going to start off where we're looking for the overall heat of reaction, and there's two ways to do it, and I'm going to show you both ways. So we're told, and this is 2019, we're told that we have tetraethyl lead 2 C2H5 4 Pb plus 27O2, and that goes to 16 CO2 plus 20 H2O plus 2 PbO. And we are asked the heats of formation of tetraethyl lead, carbon dioxide, water, and lead oxide is the three values or four values respectively, and we're asked to calculate the heat of reaction. So the method one that I'm going to show you, so this is the first way, and this is how I do it. Firstly, we're told the heats of formation. Okay, so straight away, we're looking at heats of formation. They're going to be on my product side. And I have tetraethyl lead. So tetraethyl lead, C2H5 4 Pb. And that has a value of 52.7. I have carbon dioxide, which is CO2. And that is a value of minus 393.5. I am given water, which is H2O, and that is minus 285.8. And finally then I have lead oxide, which is PbO, and that is minus 219.0. Okay, so what we're going to have a look at now is we're going to have a look at how each of these are actually formed. Okay. So, firstly, I have in total 2 by 4, which is 8 carbons. Plus, I have 5 hydrogens by 4, so 20 in total. Now, remember with my hydrogens, that exists in its standard state as H2. So, in order to make 20 of them, I have to have 10 H2s plus lead Pb. Okay, CO2 is made by reacting carbon and oxygen, again O2 in its standard state. If I look here at water, it's made using water, or it's made using hydrogen H2 and oxygen O2. But I have 2 oxygens here and I've only 1 here, so I need to only have 1 oxygen there, so that's going to be a half O2. And here then again I have lead. So again, that's Pb, and again, it's going to be a half O2. And what we're going to look at now is we're going to look at where each of these appear on my actual equation. So, if I look at this, this is my heat of formation of my tetraethyl lead. Okay, so this here is on my right hand side. It's on my left hand side here. So I need to reverse it. When I need to reverse it, I also need to multiply by 2. Okay, because I have 2 here. Okay. So when I do that, I multiply the whole equation so by 2 and I'm reversing. So I have 2. C2H5 4 Pb goes to 16C plus 20H2 plus 2Pb. And when I do that, when I reverse this, it changes into a minus. And then I also have to multiply it by 2. Okay, which I'll do over here in the corner because I don't have my calculator without shaking off my phone. So that's 105.4. Okay. Next then we have C plus O2 goes to CO2. So I'm looking at my CO2 here. And if I look, it's on the right hand side. Okay, so both on the opposite side of the arrow. But if I look here, I've only 1 and I've 16 here. So I have to multiply this by 16. So that gives me 16C plus 16O2 goes to 16CO2. Okay, and I'll have to come back to minus 393 multiplied by 13. Okay, so I'll just actually open up my calculator here. Now the sign here stays the same, okay, and the reason why the sign here stays the same is because I'm not reversing. Okay, so I'm not doing anything here. I'm not changing its side. Okay, so because I'm not changing its side, it stays the same. So we've 393. Sorry now. 0.5. And I'm multiplying that by 16. And that gives me minus 6296. So that's that. Next then, I'm looking at my H2O. Again, if I look, it's on my right hand side here, and it's on my right hand side in my overall equation. So again, it stays to the same side, so it stays minus. And then I'm going to have 20 H2 plus 20 by a half, so a half of 20 is 10 O2. And that gives me 20 H2O. And then I have minus 285.8 and I multiply that by 20. And when I do that, it gives me minus 5716. And finally then, I'm looking at the PBO. Okay, so if I look at my PBO here, it's also on the right hand side here, so I don't have to reverse it, but I've only 1 here and I've 2 here. So I have to multiply that by 2. So then I have 2PB plus 2 by a half is 102, and that gives 2 PBO. And again here then, the 219 minus stays the same because it stays on the same side. Minus 438. So we only change the sign if we change where it goes. Okay, so if we look here, if I want to end up with this on my left hand side, it's on my right hand side, I have to reverse the equation. When you reverse, you always change the sides. So now what we're going to do is we're going to compare what we have on the left hand side with what we have on the right hand side, and anything that's on both sides can cancel. So my 16C from my left will cancel with my 16C from my right. My 20H2 on my left will cancel my 20H2 on my right. The 2 PBs on my left cancel the 2 PBs on my right. Okay, now next here then, we are looking at my number of, that's it, that's everything that will cancel. So what I have is 2 C2 H5 4 PB plus, and none of my oxygens can cancel with anything on the right hand side because there is no oxygens on the right hand side. So that's 16 plus 10, which is 26, plus 1. So that gives me 2702. And if I compare to what I have up here, 2702, so we're looking good. And that goes to 16CO2 plus 20H2O plus 2 PBO. And again, we look at what we have up here, that is exactly what I have down here. So then what do? We add up all our delta H's. So I have minus 105.4. I have minus 6296. I have minus 5716. And I have 438. And in total, that gives me an answer of minus 12555.4. Now, in the question, you're asked for 1 mole of tetraethyl lead. But here I have 2 moles. So I have to divide it by 2. And when I divide it by 2, that will give me the amount in 1 mole. So my amount in 1 mole is minus 6277.7 kilojoules per mole. Okay, that's method 1. Method 2 then. And for method 2, you have to know this equation where my delta heat of my reaction is equal to the sum of the delta heat of formation of my products minus the sigma delta heat of formation of my reactants. Okay, and in this case, I'm asked for my delta heat of reactions. Okay, so again here, my balanced equation, 2C2H5 4Pb plus 27O2, and that goes to 16CO2 plus 20H2O plus 2PbO. And in this question, I'm told the heats of formation of tetraethyl lead, 52.7. Carbon dioxide, minus 393.5. Water, minus 285.8. And my lead oxide, minus 219.0. Okay. In this question, I'm asked the heat of reaction for combustion, which is my delta heat of reaction. So it is my delta heat of formation of my products. These are my products. So whatever my heat of formation is, I multiply it by the amount of it present. So I have 16 multiplied by minus 393.5 plus, because it's the sum of, 20 by minus 285.8 plus 2 times minus 219. And it is minus into the delta heat of formation of my products. So I have 2 by 50, or of my reactants, sorry. So I have 2 by 52.7. Now, I'm given no information about oxygen. So anything we're not given information about, we just put it as 0. And what we do here now is we multiply 393.5 minus multiplied by 16 gives me minus 6296. And a plus by a minus here gives me a minus. So 20 by 285.8 gives me minus 5716. And again here, 2 by a minus gives me a minus. So 2 by 219, and that gives me minus 438. Okay, and then it's a minus again into plus, so it's going to be minus, and it is 2 by 52.7, and that gives me minus 105.4. So now I add up all those minuses together, so keep the sign the same. 6296 plus 5716 plus 438 plus 105.4, and that gives me an answer of 12555.4. Again, if I look up here, this is an equation for 2 moles. So 2 moles again is minus 12555.4, and I need for 1 mole. So basically you're dividing there by 2, and 1 mole there will give me minus 6277.7 kilojoules per mole.